This is a Brinell hardness testing machine. This machine is used to find out the hardness of the different material. Here in the lab condition we are using some of light materials like aluminium and medium hardness material like this is copper, brass, something like that, and heavy material like MS. These are using in the lab, and this is the apparatus, and this is the testing platform, and the test procedure is the forces applied for materials like light material, medium material and hard material are predetermined. The force applied is predetermined. In the testing of aluminium specimen, we are using 100 kilogram force, applying 100 kilogram force. That setup is here. Behind of this material there is a hanging load system is there. There is a defaulted load that represent 500 kilogram force. That means this is not 500 kilogram force. When the mechanism is operational, the force transfer to that point is 500 kilogram force. And the aluminium material we are tested with a 100 kilogram force. So if we add additional loads there, this is the additional loads. These load represent 250 kilogram force. So 500 here, 250 here, again add one more 250 kilogram, and that is a particular model of forces because it is around 10 kg force. It is very carefully placing here. Yes, now it is 500, 250, 250. That means its net effect on that point is 100 kilogram force. This is the testing platform, and the indenter is this 10 mm dia ball. 10 mm dia ball that is fixed there. It is not detachable. It is fixed 10 mm dia ball. That is the indenter. And the desired force is coming to this indenter and come to this plate. And we are here using aluminium indenter. Here the loading pattern is like this. It is loading condition and unload condition. Now it is unload condition, and the machine is in off position. When we start, when we on this machine, the loading condition is something like rises, and the hydraulic power as well as the electric power, the load is transferred to this point and coming to this plate. When we load this machine, and we can apply load and waiting 15 seconds here to the complete loading and unload. After that, after this process, there is a indentation like this. We can see where we used to the plate, and after that we measure the diameter of that indentation, and we go to the calculations. Now we can test a specimen. This is the on switch. When we on this switch, the counterweight is going upward, and we are placing a place. No previous indentation is here, so like that place we use for indentation, and raise this platform using this system. We can raise this platform and just the indentation point is just a touch here, and you want to look this place. The primary loading or seating loading is like this way. We can again raise this platform. Then what happen, you can see here, this large scale as well as the small scale is needle is changing, and when the small needle come to the red spot, yes, that is the small needle pointing the red spot, that is the primary loading. Now this is in the primary loading condition, it is in a loading condition. Then we load the secondary load or the actual load, 100 kilogram forces is come on here. Then the indentation process is going, and there is no changes. Now the changes is started. Now the penetration is going on, that is the movement of the needle represent the penetration is going on. When the penetration is completely over, we count for 15 seconds. The penetration is just going on, we can see. Now I think it is over. Then we can count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then unload. The loading is, this is a traveling microscope. This is traveling microscope. You can see the vernier and the main scale. This is the main scale and this is the vernier scale. And this is traveling. Traveling means this microscope is moving to and fro. This microscope is moving to and fro. We are setting the main scale as 0, 0, and here it is also 0. This one is also 0. Here it is main scale and vernier scale is 0, and you can place this, your indentation point is main scale is 0 and vernier scale is also 0. Then you place this indentation just below the microscope and take the diameter of this indentation, both direction, x direction and y direction, the maximum diameter. The mean diameter is the original diameter of this indentation. After you got the diameter, you can a simple calculation and you get the Brinell hardness value of this material.